Hello. This time we consider a 2 by 2 matrix where one of the coefficients is a prescribed real number and with some additional conditions on the entries of this matrix. And we want to know under what values is that matrix is invertible. Well, here we have to recall a few things. So, recall that n by n matrix, so a square matrix, is invertible if and only if it is non-singular. Meaning that its set of columns forms a linearly independent set. But also that may be reduced to something a little bit more mechanical, having to say that if and only if its unique row reduced echelon form has no zero rows. This would be equivalent as to say that its unique row reduced echelon form is identical to the identity matrix. Well, at least in this case, right? Under this context. Well, we're going to use that because that's a little bit more mechanical. So it's for us a little bit simpler to manipulate, and we'll see where we get. So we start with our matrix 2b squared 4b. We have no additional information about b other than that it is a real number. Well, but even though we can perform some reduction process, right? At least partially. So we have row 2 subtract twice row 1. And from that we get the following matrix. 2b squared 4 minus 2 and 2 minus 2, b minus 2 times b squared, which of course we just summarize into 2b squared 0 b minus 2b squared. But now at this moment, there's only one thing that we can do. We can ask, is this number 0 or not? Now, case number 1. Suppose that b minus 2b squared is different from 0. Well, if that is the case, what we can do is from this matrix we perform a reduction. What reduction? I'm going to multiply row number 2 by the reciprocal of this number, b minus 2b squared, and apply it on row number 2 to get a matrix of this form. 2b squared 0 1, and then from that point I need to get rid of this entry, and I can do it by taking row number 1 and subtract b squared times row number 2. That would guarantee that I get 2 0 0 1, and lastly I will take half of row number 1 to get 1 0 0 1. So there you go. So I get that the matrix under the condition that b minus 2b squared is different from 0, well, that reduces to the identity matrix, meaning that the row reduced echelon form of this matrix has no 0 rows, meaning that it is invertible. Now, what about the other case? When b minus 2b squared is equal to 0. Well, when b minus 2b squared is equal to 0, the matrix that we started with, well, that we had at this stage, now has this format, 2b squared 0 0. But now we identify immediately a 0 row. This is a singular matrix. right? Well, if it's a singular matrix, well, what are the conditions for that to happen? Well, we solve this equation. With that, well, we can factor b. We get 1 minus 2b equal to 0, but that is the same as to say that b is equal to 0 or b is equal to 1/2. Well, what does that mean? That means that this matrix is singular exactly when b is 0 or b is equal to 1/2. So for A to be invertible, we just have to collect the data. That happens exactly when b is different from 0 and b is different from 1/2. And that's it. See you next time.